Hey everyone, welcome to the lecture video for tomorrow. Let's get started with a quick recap of where we ended last week, or of everything we did last week, rather. So we learned about the basic units. We got the meter, kilogram, and the second. Significant figures. This is really important for how you want to present work. You don't want to present work like that. Maybe you want to present work like preferably you write your numbers like let's see 1, 2, 3, 4, something like that instead. All right. Or also knowing the number of significant figures that's in a number. That's really important. Average speed, average velocity. So we learned the velocity is delta x, that's our displacement over time, and speed is distance over time. So we learned that. Vectors and scalars. We know vectors have both magnitude. All right, vectors, magnitude, and direction. I almost forgot that one there. And scalars, only magnitude. And magnitude is just another word for size. All right, think about size, how big, how small it is. Addition of vectors, we got the tip to tail. Let's have vector A there, I have vector B, then I can go tip to tail, and then A plus B, We also have the parallelogram method as well. If I go there, I go there, and then if I have A, B, then A plus B, here's my vector. All right. And all this is really good for kinematics. Kinematics is the study of dynamics. This is the of actual, we're actually getting to doing some physics. A lot of things we're just giving you tools, but kinematics is a whole physics topic that we're gonna get to. Now, this is a common way through which we have represented data last week. So basically, this is an example I got from your book, and it's supposed to symbolize a person walking from their house to their school or something like that. All right. So we have on the axis here, we have position. So this is in meters. So I have 100 meters, 200 meters, 300 meters, 400 meters, and 500 meters. And then the dots, each dots represent 1 second. All right. So t equals 0 here, t equals 1, t equals 2, t equals 3. So this is t equals 0, 1, 2, 3, and so on and so forth. We won't present data like this moving forward. Instead, we're going to rely on a two-dimensional graph. And the graph I'm about to make is called a position time graph. I'm going to show you how we can present that same exact data on this one-dimensional graph, on our two-dimensional graph. One, we already need an axis. We need an axis, all right? A full Cartesian axis. On our y, on our vertical, we have the position, x in meters, all right? This means meters, all right? And then here, our y, we have x position and m meters, and x here, our horizontal, we have t, and t is in seconds. So basically, in our vertical, we have position in meters, and our horizontal, we have time in seconds. Yeah? So let me show you how we can do this. So I need to label my axis. I need to write some stuff on my axes. So I'm going to put my distance numbers on my vertical. And on my horizontal, I'm going to put some numbers as well. We need time, all right? Because this is just 1 second of time. 8. All right. So I can see that at time equals 0, I am at the 0 point. So t equals 0, I'm at 0. Time equals 1, I'm somewhere in between 100 meters and 200 meters. So I'd say I'm somewhere there. At t equals 2, I am at 100 meters. So see, t equals 2, I am at 100 meters. I'm just getting data from there. At t equals 3, at t equals 3 here, I am close to 200 meters, but not exactly. So maybe I'm somewhere here. And then at t equals 4, this is 4 right here. I'm somewhat close again, but getting close. Then at t equals 5, I get past it. Oh, snap, I made a mistake. At t equals 4, I should be at 4. So I'm still close. At t equals 5, I get past it. T equals 6, I'm, just getting further and further. I can't believe I forgot 6. Yeah, 6, 7, 8. All right. At t equals 6, I'm past it. And at t equals 7, I am like by the 300, close past 300. And t equals 8, I'm past 400. And t equals 9, somewhere in the abyss, I'm past 500. So basically, this is the same information, but we can do a lot more with this data, with this position time graph, as we will see in this video. All right. So yeah, and I'm just gonna copy and paste this graph right here for now, just to have it ready when I need to. All right. Copy. Okay. Awesome. So just a short detour. In physics, before we start any problem, we have to we have to show what direction is our positive going to be in the x-axis, in the horizontal, if you like, or the y-axis, the vertical. So here I show that, all right? I show that here, okay? So my x-axis is going to the right, and my y-axis is going up, vertical. If I wanted to, I could flip it, but that would just be confusing. So yeah, but anyway, we know velocity. So this is velocity, okay? Velocity is equal to displacement over time. We've been singing that song for a very long time now. And because now we're slowly transitioning into two-dimensional motion. So far, we've only seen what a position time graph looks like, but later on in the weeks, we'll see what two-dimensional motion looks like. So, but yeah, basically now, because we have two different dimensions, a vertical and a horizontal, the velocities are also different vertically and horizontally. So if I have a ball just going down straight from the Leaning Tower of Pisa, that is only going down. It has no velocity. There's no horizontal velocity. So this, I could clearly call this my y, and it's going downwards. Because it's going downwards and my positive is upwards, it's going to be in my negative vy. So negative velocity, subscript y. And if it's going up, it'll be positive, but it's going down. And then if I have something going to the side, just like this, similar, it's going to the positive direction, same direction, it's going to be vx. All right, this is just be vx. So what we should distinguish between vertical motion and horizontal motion when talking about our velocities. All right, we should always distinguish between vertical and horizontal motion. So here I say, before attempting the question, ask yourself, is the motion vertical or horizontal? All right, horizontal. Assign a particular vy or vx, this is respective, to your velocity. And this is all about naming, just to say, if someone's walking like on a street, that's definitely horizontal motion because they're walking. If someone's jumping, so either I use vx, and someone's jumping from a cliff, hopefully no one's jumping from a cliff, unless they have a parachute. That's clearly vertical motion. So yeah, and here just a quick note: speed is just to remind you guys, it's the absolute value. The absolute value. All right, absolute value of the velocity vector, and it's also a scalar. All right, so speed's always positive. So let's go back to our time graph now. All right, come on, paste. Nice. All right. So what if